Hello guys, welcome to my channel and our video of the playlist called C# for beginners. Okay, let's start with something that's probably happened to every single one of you already at some point in this series, even if you didn't realize what's going on. So let's try this code. So let's run this. Example, enter number. So you entered 435. Fine. Looks fine, right? Now watch what happens if I write something like banana. Okay, look at that unhandled exception system. Yes, see that the whole program just dies, crashes completely, ugly error message, and the user has no idea what actually went wrong from their side. In real world, this is genuinely unacceptable. You can't ship software that just fails over the seconds someone does something unexpected. So today we are learning exception handling, how to catch these problems gracefully and actually do something sensible when they happen instead of just crashing. Okay, so the core tool for this is something called try and catch blocks. Let's fix this example with try and catch. Okay, uh, let's try with it banana now. See that? That was not a valid number. Okay, huge difference already, yeah? Let's break down what's actually happening here. Look at here. We take a risky code inside the code that might fail and wrap it inside a try block. C# then attempts to run everything inside there normally, but if something goes wrong pathway through like a int.parse choking on banana, instead of crashing the whole program, C# immediately jumps down into the catch block instead and runs whatever we put there. And notice this really important part. Look at that line. Program continues, for example, here. We can add here to prove that program continues to working, continues normally. Normally. We can show that program continues normally even if we write banana and, for example, banana, yeah? That was not a valid number and continues normally. That means after catching error, the program just does not crash and stop. It works, okay? So what if we did without try and catch in the previous section, if you remember? Let's do something like that, yes? Mm, let's delete this and let's try this now. If I write now banana, it just crashed and we don't see this continuous normally block. See that difference? So that's why we need to learn how to handle the exceptions gracefully and smoothly. Now, just saying something went wrong is fine, but honestly, it's not always that helpful for us as developers or sometimes even for the user. Wouldn't it be nice to actually know what specifically went wrong? Turns out we can. So let's try this another. one, not this one actually. Let me uh, get it inside try block and then catch block and then here uh, and so dot right line. Something went wrong. Console exception x dot right line x dot message. So let's see the error. No, banana. Something is wrong. The input string banana was not in the correct format. See that? Exception x part now next to catch. Yeah, that's capturing the actual error object that occurred and naming it x. That's just a common convention, short for exception. Nothing special about the name itself. And once we have it, x.message gives us the actual specific description what went wrong. In this case, something like input string was not in correct format. Yes, this is honestly really valuable while you are developing and debugging instead of guessing what broke. The exception tells you directly. Now, here's something worth knowing. Not every error is the same kind of error, and sometimes you actually want to handle different types of problems differently. Let's look at slightly bigger example. Try console dot write line enter a number to divide 0 by int. Let's run this now. Okay. Let's try this number. Result is 0 because whenever we divide 100 by 124, it would be literally 0 in terms of int. So let's try with maybe this one. That was not a valid number. Okay, so let's actually test this properly. Okay, what's going on here? Whenever we type in banana, the error catches the format exception. Since the parsing text into number is what actually failed. Then we tried with 0. Okay, instead completely valid number. So parsing works fine. For example, let's try with 0 here. 0, you can't divide by 0. That means divide by 0 exception, and it correctly jumps to the second catch block instead. And the last more generic one is catch exception x at the bottom. Think of it as a safety net. It catches literally anything else we didn't specifically plan for. Genuinely good for practice to include one of these at the end, just in case, okay? One important rule here though, C# checks these catch blocks in order, top to bottom, and stops at the first match. So more specific exception types always need to go above more general ones. If you put that generic exception catch first, it would actually catch everything, and your more specific catch below it would never even run. Worth remembering, okay? One more piece to this puzzle. Sometimes there is code you want to run no matter what, okay? Whether the try block succeeds completely or failed and got caught. That's exactly what finally keyword is for. Let me show you this. For example, we can write here, enter a number, just number, divisor, enter, just enter it, and only format exception, does not end, here is, finally, oh, not right line, let's try this. Enter a number, this one, entered 35, this always runs no matter what, see that? And let's try with invalid case, banana. This was not a valid number, this always runs no matter what, okay? See that this always runs no matter what happened. It prints both times, whether we succeeded or failed. Finally, does not care what happened above it. It always executes. So when is this actually useful? Classic example, imagine you opened a file or a network connection, yeah? Somewhere inside your trial block. Even if something goes wrong pathway through, you still absolutely need to close that file or connection properly, or you risk leaving resources locked up. Finally guarantees that cleanup code runs success or failure every single time. Got that? Alright, so everything so far has been about catching exception that C# throws at us automatically. But here's something interesting. We can actually throw our own exceptions to deliberately when something in our own logic does not make sense. So let me show you code, example code for that. Okay, maybe void set age integer age. If age is less than 0, throw new argument exception. Age cannot be negative. Yep. And then here we can write console.writeLine age set to age. Okay. Now let's try this. Set age 25. Set age -5. -5. Okay. Okay. And then let's run this. .NET run. Okay. Age set to 25 and unhandled exception. See that? Throw new argument exception. We are deliberately creating our exception here with our own message and forcing the program to stop, because realistically a negative age just does not make sense, and we want to catch that mistake as early as possible rather than letting bad data silently flow through our program and cause weirder problems, yes, somewhere else later on. Now obviously, if we call this without dropping it in a try catch, it will crash our program, same as in any other exception. So typically, whoever is calling this method would wrap it appropriately. Let me show that. Try set age -5 and then catch argument exception x console.writeLine error x dot message. Uh, let's run this now. Error age cannot be negative. Now this it's handled gracefully instead of crashing. This pattern validating input and throwing a meaningful exception when something goes wrong. It's genuinely everywhere in real professional C# code. Last thing for today, sometimes the built-in exception types like argument exception or format exception don't require capture what actually went wrong in your specific application. For that, C# lets us create our own entirely custom exception types. So let's see that with example. Okay, so we're gonna create class, for example, insufficient sufficient fund exception, and then we're gonna get inheritance with, from exception class public insufficient insufficient oh insufficient exception sufficient exception. Here we're gonna get string message, and here base message and here we'll have maybe void withdraw double balance double amount, and if amount is greater than balance, throw new insufficient fund exception, uh, cannot withdraw, withdraw amount, balance is balance. And then we're gonna write here console dot writeLine withdraw withdraw amount remaining balance, maybe remaining balance minus amount. Okay, and we're gonna let's get upper part of the class. Okay, and now it works. And then we need to try and catch it. Okay, here we're gonna withdraw maybe 100 and 500, and then console dot writeLine transaction failed. Here we're gonna catch insufficient find exception and exception error plus x dot message. Okay, let's run this. Error cannot withdraw 500, balance is 100. See that? Okay, now few things here. Look, class insufficient exception, getting inheritance from exception class. Remember that colon from a couple lessons back. Yes, that's inheritance. And on exception class, it goes the same underlying behavior, message included. Because as you can see here, we are giving to base class. That means the exception class. We are calling that calling the function. We are calling the exception class and giving the when initializing, giving the message to base class also, because we are initializing our custom class with exception class. Okay, now our message, error message, are actually meaningful to our specific application. Insufficient funds means a lot more at a glance than a generic error ever could. This is honestly a really nice touch that separates beginner code from more professional, thoughtfully built applications. Okay, so let me put all of the things that we've learned together. Okay, class negative deposit exception, exception class, public negative exception class, string message, base message, class bank account, bank account, public double balance, get private set, public bank account double starting balance, balance equals starting balance. Now public void deposit double amount. If amount 0, throw new negative deposit exception, deposit amount cannot be negative, negative. And here and balance plus equal amount. And here public void withdraw double amount if amount greater than balance, throw new invalid operation exception, insufficient insufficient funds, else balance minus equal amount. Okay, now we're gonna create our bank account back bank account, maybe it's $100. Then we can try account dot deposit, maybe minus $50, and then catch negative deposit exception x console dot writeline x dot message catch invalid operation exception, invalid operation exception x console dot writeline x dot message. Finally, console dot writeline current balance is x dot balance. Okay, so let's run our code. Okay. Deposit cannot be negative and current balance is 100. And here we go, a custom exception. As you can see, we've used all of them. Custom exception, multiple catch blocks, handling different problems differently, and finally a block guaranteeing we always print the current balance no matter what happened above. Okay, this is genuinely disclose how real applications and work, banking, software, e-commerce systems, anything handling real data actually protect themselves from a bad input and unexpected failures. Okay, so I think that's all for today's lesson. And then at conventionally, I'm gonna give you one mini challenge, mini example of to write at home and practice. Your challenge would be writing a method called it set grade, and parameters would get integer type score that throws a custom exception, invalid grade exception. If the score is below 0 or above 100, wrap a call to it in a proper try catch and add finally block that prints grade check complete no matter what happens. Okay, so today we covered try catch block for handling errors gracefully instead of crashing, reading exception messages, using multiple catch blocks for different error types. The finally block for guaranteed cleanup code, throwing our exceptions deliberately, and finally building fully custom exception types with meaningful messages. Yes, exception handling is honestly one of those things that separates code that just works on a good day from the code that's genuinely production ready. Next time we are moving into generics, writing code that works flexibly with multiple different data types. So see you there. Take care.